All right, so okay, start with optics. Now, first, let me ask you, what is the difference between a real image and a virtual image?
So a real image is like flipped um when it comes through the lens.
Oh, so tell me conceptually.
So I guess like a real image, you're like kind of looking at it like head on, when a virtual image, like you're not looking at it directly.
So, have you ever used like, let's say, your phone to like, let's say light is coming in, and I can, well, maybe I could even show you like this, like, okay, right now you can you see kind of like the reflection in that?
Wait, hold on. Try and make you bigger.
Or maybe I could think of a better or a different, let's see how I can put this. Okay, so let's say that there's a mirror and there's a wall behind. So like let's say this is you in front of this mirror, which I'll just write M, and then this is a whoops, a wall behind you. Okay.
Hmm.
Let's say that this is a laser pointer, okay? And you shine it at the mirror, what would happen?
So the light would reflect off of the mirror.
And like let's say it can hit this part of the wall, right?
Yeah.
So like okay, let's say like I guess like theoretically, like let's say you are let's say okay, let's say if we didn't have the map, I mean sorry, the wall. Um and I guess we could both agree that it's not good to have like a laser shine in your eye.
No. Yeah.
So would this person be in a good position?
No.
So actual photons are leaving the laser, hitting the mirror, bouncing off the mirror, hitting the person's eyes, right?
Hmm.
So actual photons, right?
Yes.
And if you were here and if you were here, and let's say this is like where the mirror ends, so you're, like there. Um, Meaning, so like this stick figure on the right is not on the other side of the mirror. It's just like on the right here. Um,
Mhm.
this, oops, light here. Tell me if, tell me which of these two people could see it, and or if none, or if both.
So I definitely feel like the person on the left could see it, this person right here. And I'm not quite sure. I don't think the person on the right could see it.
Okay, so. let's say maybe it's like the positioning that I did. So let me maybe draw like the person here. What about this person?
I could see the light then.
Okay. Okay. So now back to this mirror. So this I'll use light blue here. So this is this person's reflection in the mirror, right?
Hmm.
And now is this reflection um like are photons from this reflection like, coming out of the mirror?
No.
And could and so this person can see the reflection. What about these other two?
I feel like the person on the left could see the reflection as well.
Okay.
Um, Person on the right, no.
No, right? So a real image is one that could be projected. In other words, can be actually composed of photons, right? Whereas a virtual image, as the ones that you see in a mirror, like when you see your reflection in a mirror, that's really not able to be projected because it's not a real image because it's as if it's inside of the mirror, right?
Hmm.
So, like, like another example I would give would be like what I was, I guess, kind of trying to do with like oh, this does work. Okay, okay. So check the, okay. So right there, like,
Yeah,
what's this? You see how
it
it's,
looks, is that like your window?
see how I can do um, and I don't have like a laser near me. Maybe I could use a flashlight.
Okay, yeah, I see what you're saying.
Oh, that didn't work. But okay, because like I was also gonna ask like but you're not wearing a watch or anything like that.
No, not today. I normally have a watch on.
Oh, okay, okay. So let's say that like I don't know, like this is like your watch, right?
Hmm.
And have you ever like used like let's say light to like kind of reflect off of the watch and like be kind of like projected onto like a wall or something like that?
Yeah, yeah, I've seen that before.
Okay. So like that means photons are actually here, right?
Yeah,
And so this is you creating a real image using your watch. Okay.
gotcha, gotcha.
Now, like now in contrast to that, so like with my phone I'll use, I couldn't get like the angle of like, to get the thing to shine, but like if I did, I would have shined it at the webcam and it would have produced some type of I don't know, some type of light that would hit the webcam, but now for here you can now see the reflection of the well, this is really my monitor, right? And that's like you and me right there. Now this is not um something that can be projected, right? And if I was here, right? I mean like well, not even just this. If I'm here, I mean the only reason I could see it is because of the camera, but if the camera wasn't here, I would not be able to see your reflection here, right? And that's because this reflection is a virtual image, right?
Hmm.
And like if you
Yeah.
look at your watch itself and you see your own reflection, that's a virtual image, right?
Yeah.
Okay. So so any questions about that so far?
I feel like I understand the real image because yeah, it's like composed of photons and it's kind of like it's basically based off of like where the light is hitting from my understanding.
Hmm.
But I'm still a little confused about the virtual images. Like I feel like maybe it's like I get it because like what you're saying is like when you hold the phone to the camera and you see that reflection of me on your phone, like that's the virtual image itself.
Yeah. So basically when you look at your phone and you see your reflection in the phone, it's not like the photons are like hitting your eyes that are coming from the phone. The photons already exist like in your surroundings and you can see your own reflection in it. Um, but someone's, sitting someplace else cannot see it. So, um, yeah, so that could be,
So I feel like the virtual image is something that you could see, but someone else can't see.
hmm.
Okay.
Yeah, I was trying to find if there was an example, like a clear example or not. But yeah, basically like you know, um so yeah, if it I guess like you could ask yourself so yeah, I guess you could ask yourself like, okay, is this um maybe the simplest way would just be like asking yourself, is this an image that can be projected? Okay? And if
Like
it yeah.
I guess like projected from what? Like a like like in the con like in the frame of like a projector? Like
So so like even that I don't know why this whiteboard going so slow, but here, like even in this example, right? You are so yes to your answer to your question about like a projector, like in a movie theater,
hmm.
but also something like the laser that I drew, and also like the watch thing that I drew,
I see what you're saying. Okay. Okay.
right?
Okay.
So um so yeah, if I just was looking, so yeah, that's the idea. So like um between virtual and real um image and now so I drew this as like a plane mirror, which is just a straight mirror. Oh yeah, and then well, I guess there would be a okay. So this is the virtual image of this laser pointer. Okay. But this is that real image. Okay.
Yeah.
Okay. Now let's talk about so now lenses and mirrors that we talk about are whoops. Okay, so the mirrors and lenses that we talk about are called spherical lenses or mirrors. And that's because if you take like let's say two spheres here and let's say they are not overlapping, the in-between region forms this shape. And what would the name of these two shapes be? And by shapes, I mean the light blue.
Oh, those are so the top one is convex.
So if we start off with, let's say, let's just say like a regular rectangle, or rather something like that. Oops. What's a cave?
A cave.
Mhm.
Um, it's like a hole
What's a
within the.
cavity?
Oh, a cavity is like that's like a hole in your tooth.
And but it could also be an opening in your body.
Yeah. Hmm.
So if you imagine like making kind of like a hole here and here, right? You would get this type of shape, right?
Yeah.
And this is I don't know why this is doing like this. Okay. This is concave,
Oh, okay.
right?
Yeah, I see what you're saying.
So think like super into interdisciplinarily, like in life, it's always beneficial that way. So it's like, okay, because at the end of the day, and like this is kind of like on all of our time working together, like you probably got this, I like kind of vibe, but it's like I don't think it's very good to just be like, this is concave, this is convex, remember it. I want things are there's often simple kind of explanations and connections between things that could be overlooked if you just relied on the memorization part. So that's why I asked you, like, okay, what's a cave? You said a hole. Cave, what about a cavity? A hole in your teeth. A different type of cavity, like body cavity, is a hole as well. And so if we start with a regular rectangle and we make holes in it, kind of, we can get a concave shape, which in other words would mean that it's thinner in the center compared to at the ends. And then, so this one would be convex, right?
Yes.
And that's where it's thicker in the center.
Mm-hmm.
Okay. Now, for diverging optical devices, what does that mean exactly, like diverging?
Diverging means that like when the light rays are coming in, like they don't all meet at one point. They kind of like spread out from
Good,
each other.
good. So if you had a, okay, so if it was, so I drew a concave shape and a convex shape, and in order for them to be diverging, which one would be like a mirror and which one would be like a lens?
In order for it to be diverging. Okay. Um, so I feel like diverging a diverging lens is has like the it has the converging lens.
But can something be diverging and converging?
No, no, that doesn't necessarily make sense.
Mhm.
Um,
So,
okay.
what's the difference between, like, I guess, what's the main difference between a mirror and a lens?
You could see through a lens, but the mirror like reflects back to you.
Um, well, tell me, so this is kind of like when I asked you about real versus virtual. Like you were telling me something about like upright or whatever, but like what is the difference between the lens and the mirror, right? Because you could tell that's like, like if I ask you like what's uh I don't know, like if I asked you like what's an apple and I was like something that you eat, tell me like mhm.
Um, okay. The
I know it's like a vague question.
well, yeah, I was just trying to think about all the videos that I watched about lenses and
Just,
um
just think naturally. Like it's all about instead of trying to remember things or videos, just straight up.
okay. Well, I feel like lenses can also like magnify things as well. Or
But you're telling me like some properties. So tell me like, you know, because you could have magnification with mirrors. You could have, all sorts of stuff like that can happen. So just like, so here, I'll tell you what I mean. So like, which is fundamentally, right? So, um, okay, so my glasses are lenses, right? Right?
Yes.
and it allows me to see things. If they were mirrors, I wouldn't be able to see anything, right? Except, I guess, my reflection.
Hmm.
So if you have a lens, you would have an, well, you would want the light to go through it. But if you have a mirror, you want the light to not go through it, right? So
Yes.
so if we imagine something like this, and then also another kind of thing that can help, like when I'm saying like help, I mean like conceptually, right? Because it's all about that's the most important thing, conceptual understanding. So like, okay, so how can I tell like which of these is going to be diverging or not? Um, so this convex shape, I can exaggerate to make it more like this, right? Like let's say something like that. And now in World War II, the most effective tank was the Russian T-35 tank. And the reason is that the front of the tank had this shape. Okay. Now, when they shot like a shell at this, like a artillery shell or like a, bullet or whatever, it would cause it to reflect away from it, right? More so, well, not a right angle, but more so like this, right?
Hmm.
And so, that's why it was so effective because compare that to like if you had just something straight like this, where it can concentrate all of its, energy on this point and then penetrate. This way, it causes it to deflect at an angle. Okay. Now, since mirrors behave like this, because mirrors don't let light go through it, forces light to bounce off. Same thing here. So that means that your convex mirror will be a diverging optical device. Okay.
Yes.
And then for the lens, a lens is something like functionally defined as where you have light go through it. If it goes through a concave shape, it will cause it to diverge. Okay. And, and I put the M here to mean mirror, the L here to mean lens. And so
Mhm.
so if you have a concave lens or a convex mirror, they will be diverging.
Okay, that makes sense. So,
And now the type of image that a diverging optical device produces will always be SUV, which stands for small, upright, virtual. And oh yeah, and then since the thin lens equation is 1 over the focal length is equal to the reciprocal sum of the object distance and the image distance. And a focal point or a focal length is something that is intrinsic to that optical device, meaning you can't change that. But of course, you can change the object distance, which can then affect the image distance. This equation is going to be very important. And there's also the magnification equation, which is the ratio of image distance to object distance.
Okay.
So, um, yeah, so diverging will always do SUV regardless of the object's position. And let me throw in a sign convention image here. So for lenses, if you're um, to the left of the lens, the sign is going to be positive. And if it's, sorry, negative. And if it's to the right, it'll be positive. And if it's up, which means upright, it's going to be positive. If it's inverted, it's negative. And your focal length, do you wear glasses or anything?
No.
All right, you're lucky. So you have a focal length, or well, you don't have focal, but yeah. So for a lens, if the focal length, the if it's converging, aka convex, the focal length will be positive. If it's negative, the focal length, it'll be concave or diverging. So okay, so now for converging. Optical devices, which include convex lenses, or concave mirrors, your image it will be uh, dependent on the object distance. So I'm going to draw like a plane here and a oh yeah, and then I should also say that there's a so f here is the focal length, and then 2f is related to something called the radius of curvature, which comes from the fact that these are spherical mirrors. Um, but so I will label f 2f, then f 2f, and I'm going to use an arrow. So let's say that this arrow on the left is the object distance. So um Okay, I'll make like a table. So like, so this O, by the way, just it doesn't mean zero, it just means object distance. And then the I means image distance. And then like the type of image will be in this last column. So let's say that the object distance is beyond 2f, like this object, which I drew as an upright arrow here. It's further than 2f, right?
Yes.
And like, and you can plug the numbers into the thin lens equation, but I'm just gonna like kind of do that for you so you have like this table that you can use. Your image distance will be between f and 2f.
Wait, okay, so it's here, right here. Object, image.
So this is a lens that I drew.
Yeah.
So remember about what lenses are
Oh, yeah, they let things go through, so it's here. The image would be here. Okay, gotcha.
correct. Um, and now the magnification is the image distance over the object distance. Um,
Mm-hmm.
so and of course, like if the magnification is one, it's same size. If it's less than one, it's smaller. If it's larger than one, it's larger. What would it be for this image? Meaning, will it be smaller, larger, same size?
I think it'll be smaller.
What's your reasoning?
Because well, the object is greater than 2f, so the denominator will be bigger, and I is in between f and 2f.
Okay. So when you say the denominator is bigger, bigger than what?
Then the numerator.
Perfect. Good. So you're thinking in terms of like the ratios that we talked about before,
Yes.
right? Because like a lot of people would be like, well, oh, what do I plug in for I or something, right? But we don't need to know that because we know that it's smaller than 2f. So this is going to give you a small inverted real image. Okay? That will be located between f and 2f. So something like that.
Gotcha. Okay, that makes sense.
Okay?
Okay. Yeah. Okay, I feel like it's clicking.
Hmm. All right. Next, how about if object distance is right at 2f? Oops. Now what?
I still think that it's going to be smaller, smaller inverted real image because,
Well,
um,
you have the equation.
yeah,
So
yeah. So, because I is still in between F and 2F, right?
you tell me.
Yeah. So I also think it's smaller. Oh, you're talking about the thin lens equation. Okay. Oh, well. Have to keep. Okay, wait.
So yeah, so thin lens equation, but in general, right? Let's say you have A plus B equals K, and if K is a constant and you decrease A, what must happen to B?
It'll go up. B will increase.
Yeah. So when I so when you said like, this equation here, like it's a little, it's less about the specifics of this equation, but it's more about, so we established that focal length is constant for an optical device, right? Like it doesn't change.
Yes.
So this is essentially just saying that like the sum of like, I know it's a reciprocal sum, but still like the sum of like the object distance and image distance is equal to a constant. So if we reduce the object distance, what must happen to that image distance?
It'll increase.
Okay. So
So
yeah.
I guess maybe because I'm like, well, wait. I guess I'm confused. Like, what is the focal length constant? I guess we don't necessarily need to know that.
So yeah, so it's an intrinsic property of okay, here one sec. So when I was talking about the spherical, um the fact that these like convex concave optical devices are spherical basically means that your radius of curvature, radius of the actual sphere that it's composed of, gives you your focal, or rather, like, I guess your diameter, which is twice. Uh, what can I find? Uh, sure. Okay. Yeah, I don't know why I can't find a good thing, but for the spherical mirrors, the radius of curvature is the radius of that spherical, the sphere, which is going to be, so the focal length is going to be half of the radius of curvature. And yeah, and then your focal length is half that. Here, this can help too. Um, yeah, so here, this is the radius of curvature, which is the same thing as, let me go back to like, but basically your focal length is related to the yeah, okay. Your radius of curvature is equal to 2f. So half of the radius of curvature is the focal length. Okay.
Okay.
And now, and then this picture here, you can see that the focal length is when, so like for a convex one, it's the time or the length it takes to converge. So we're shooting parallel light rays here at the convex lens, and that causes it to converge. So the distance between the center of the lens and the point at which they converge, like maximum convergence, is your
Mhm.
focal length. And then if
Okay.
yeah, and then if you're dealing with a concave lens, which would mean it's diverging, you can see we also have the parallel light rays, which then diverge, moving outwards. But if you trace backwards that divergence from the beginning, like essentially you trace it back to where it converges, that length between that point that you trace it back to and the lens itself is your focal length.
Gotcha.
And so,
Um,
yeah.
I mean, this doesn't have anything to do with what we've been talking about. But my friend was telling me, like, on her exam that they were asking her about diopters. I see it here. Is diopters just like a unit of measurement, I guess?
Yeah. So, yeah, good question. So, our 1 over F in centimeters. Oh, my bad. In meters, because typically we're going to be using centimeters. But if you take 1 over F in meters, you get the power of the lens, and the unit will be diopters. So for me, my glasses will have a power, or so my glasses prescription is um well, a sign, which I'll ask you after I kind of cover some more stuff, but well actually I can just tell you. So well, I'll tell you after. So, but yeah, my prescription is 2.75 diopters, which is like the prescription of my glasses. Um, but but yeah, that's what the power is. Yeah. So yeah, you have to know it.
Okay.
Hmm.
So is it the same thing? So it's the same thing as 1 over the focal length, it's just the power of it?
Yeah, it's one over the focal length, but in meters because they're gonna by default give you focal length, object distance, image distance in centimeters.
I see.
Mhm. Okay, right.
Yes. Okay, that's clicking. It's clicking. I don't know. I'm sorry. I could be a little slow. I'm just a little tired.
No, no,
Sorry.
no. Like that's how people learn. So yeah, you don't have to apologize for that. That's literally like, what we're meeting here for. So, uh, okay. So now if we have, so if we go back here, and I'll continue the diopter like thing like in a bit. Now, but yeah, so here for if the so back here if the object distance is 2f, and if we plug it in here, right, we have 1 over f is equal to 1 over 2f plus 1 over image distance. Um, how do we do the math here? And I'm asking you because we did something like this before, but I think you're having some trouble with it. So tell me, what do we do here?
So I would multiply the 1 over image distance um by 2 over 2.
The 1 over,
Wait,
yeah. So we're trying to find what?
the image distance.
Good?
Well, I guess yeah, we're trying to find the image distance and uh have it equal to like when it's added to 1 over 2f, have it equal to 1 over f. Um, so I'm like, okay, yeah, maybe I would just multiply the image distance by 2f over 2f.
Um, well, what?
No.
Uh, yeah.
Well, what I was trying to do was have the image distance have like the common denominator of f, but I'm not quite sure how to go from. Oh wait, you know what you could do is set the image distance to 1 minus 2f, maybe.
Well,
1 no, 1 over f minus 1 over 2f.
yes, yes, good. So,
Yeah.
because if you did this, you would, well, first of all, you can't just multiply like the way it is here, you can't just multiply it like this.
Yeah,
But
I know.
but you would still get like you would still have I.
Yeah. Oh, yeah, I was like,
What you want to do is you want to isolate I first, right? And to isolate it, we need to get rid of this guy, right?
mm-hmm.
So then we can subtract that. So 1 over f minus 1 over 2f equals 1 over I, right?
Yeah, and then we would plug that in for I.
What do you mean, plug it in for f?
In terms of like trying to, I guess when we're trying to figure out like the focal, I mean, well, the this part here,
So we're trying to find
like,
I.
yeah.
So so what do we do now? So first step we isolate it. Now what?
Um, so I was thinking we would do 1 over f equals 1 over 2f
Wait, so you're saying 1 over f equals 1 over 2f?
plus 1 over f minus. 1 over 2f.
Hmm?
Like I was think I mean like I guess we don't necessarily have to do that, but I don't know. I
Uh,
that's where my
So we have to do this, don't we?
oh, yeah.
Hmm. So
Um so then it will be minus I guess a minus 1f minus 1 over 1f.
uh if I did 1 over x minus 1 over 2x, maybe this can help.
Oh, okay. Um
So if you're adding or subtracting fractions,
you have to get like a common denominator. So then I guess you would have to multiply by 2f over 2f or 2x over 2x.
um, that would get you 2x squared on the bottom. But
Okay, then 2 over 2.
yeah, good. So here we could do 2 over 2 times this to get 2f, or sorry, 2 over 2f, right?
Mm-hmm.
And then we can do minus 1 over 2f to give you 1 over I.
Yes. And that'll just be 1 over 2f equals 1 over I.
Good. So what's I?
1 over 2f.
Uh, I itself?
Oh, I is 2f.
Yep. So this equals 2f, right?
Mm-hmm.
Now, what do you think, what type of image is this going to be?
Magnification is.
Yep, magnification is, well, there's a negative, but image over object.
So it will be the same size. There's no magnification.
So magnification would be 1,
Yes.
and it'll be same size, inverted real.
Same size inverted real. Okay.
All right. Next, let's say that the object distance is between f and 2f, and we could use the formula, but you might start to see some type of pattern.
So I think the image distance will be bigger than 2f.
Look at you. You got it.
Yeah.
All right, now what?
So then it would be larger inverted real.
Yep. Mm-hmm. Very good. Oh yeah, I forgot to draw like these. Okay.
Wait, is it okay?
Yeah, what's up?
Is it greater than f or 2f? The I.
Oh yeah, yeah, you're right.
Okay, just making sure.
Good catch. So let me so okay, for the 2F thing, I made it blue. Then here I'll just get there, and then I'll use green for that. And then this, and it's larger. Good, good, good. And then we could say, okay, so this one, so if the object distance is actually equal to the focal length, you're going to get an image distance of infinity, which basically just means no image. And then lastly, if your object distance is within the focal length, your image distance will be beyond the focal length, except on the opposite side. And when I say opposite side, I mean from what's normal. So like for a lens, what's normal is object to the left of the lens, image to the right of the lens. And for a mirror, what's normal is object to the left of the lens, image, to the left of the lens. Um, so now for lenses, since we're talking mostly about that, this beyond 2f part will be on the other side, on the left side of the lens. And this will also be a negative number. So you're actually going to get, so let me draw the arrow. So this is going to be, make it orange. So here, this is going to produce an image that's beyond 2f on this side, on the left side of the lens now. Okay? And the size of it will still be large, but this time it'll be upright virtual.
Okay, so just like switches sides.
Correct. Um, and then now since it's a virtual, so like the virtual images will be always upright.
Yes.
And so I used to say real images will always be inverted, but I'm going to change that to me. So instead of inverted as an adjective, think of inverted as a verb. And the reason I'm saying that is because there's an exception I saw once where you have, oops, where you had a two lens system. So let's say that the first lens produces this inverted real image. Oh, and then I should also say your real image, in addition to being able to be projected, can be treated as an object. Okay? So that means that this, which is the inverted real image of this object, for the second lens here, it can treat this inverted real image as an object. And,
Okay, then.
yep. And then it will invert the inverted image.
So then it will be upright and virtual.
So now this is the exception here where you can have a real image end up being upright.
Oh,
But that's why the inverting the instead of using inverted image as an adjective, I'm using it as a verb. Because so this is your object. This is the inverted image. This is the inverted image.
okay.
So aside from an exception like this, you will never see an upright real image. And and then what's always true is you'll never see an inverted virtual image. So a lot of questions you can eliminate choices right off the bat by just knowing that simple fact.
Hmm.
Um, and then also this like kind of optics table. So I mean, yeah, so we worked out how to get these values doing like the calculations here. So always good to, be able to do that. But for like, drawing out this table could be like a shortcut of doing that. I know that when I took my test, like in the first 15 minutes or whatever, when you have the tutorial, I would just brain dump onto the, scrap sheet. And I would just draw out this, optics table so I could just, reference it.
Okay, I didn't realize you could do that. I'm
Yep.
like, I always skip the tutorial. Maybe I should use that time as well. LOL.
Yep, yep, yep. Yeah, just a brain dump, just put it all out there. Like, you may need it, you may not, but it's a good use of the time. So, so yeah, that's basically the type of images that you'll get for like any of these types of like lenses and mirrors and stuff. Any questions?
No, no. I feel like yeah, it's making sense to me, like, especially with the table. Like, I feel like I'm probably just gonna have to, like, draw through, like, work through the table again and make sure I understand, like, how the equations work with each other.
Yep. So then the last thing here is application of it. So now the average uh like whatever length of the eyeball is 2 centimeters, and the lens of our eye is a converging lens. Um, and they, let's say these are two light rays, they converge, and they are supposed to converge onto our what part of our eye?
The retina.
Yes, which is
Okay.
like back here.
Hmm.
So this is for like let's say your eye. Now, if your eye is longer than 2 centimeters, the light rays end up converging in front of your retina, which gives you like a blurry image. So how could we remedy this?
We could, I guess we'll have to like adjust the length of the
So you would need a doctor to be able to, and I don't even think
not
they could do that. They'd be like, all right, we have to shorten your eyeball.
um well, I guess like yeah, that's like the lens would come in and I guess change the angle. I guess it wouldn't necessarily be like the length of like the rays, but I feel like they would have to like see if they could maybe change the angle so that it converged onto the retina.
So the problem here is it's converging too much, right?
Yeah.
So what type of lens can kind of like delay the convergence a bit?
Um Probably a diverging,
Hmm.
yeah, the concave lens.
Yep. So now when the light hits the lens, it can between like the lens outside or back part and the lens hitting your eye, it diverges it so that when it then hits your eyeball, it delays that convergence. And of course, you want to get it on, with the right focal length and stuff like that for it to be able to focus that light ray onto your retina, like directly onto your retina, right?
Yeah. Oh, okay. That's pretty neat. That's how it works.
Yep. And so this is called myopia, nearsightedness. And that's why my glasses, like, if I like kind of feel it, it's thicker around like the periphery, like around it per lens, but thinner in the center.
Okay. Yes, that makes sense.
And then for the someone who has an eyeball that's shorter, the problem they would encounter would be that the eyeball has the convergence happen too late, like behind the retina. So they would need a converging lens to converge the light rays sooner so they land right on the retina. And that's farsightedness or hyperopia. Okay. And then the last part here is as people age, so like if you're looking at something far away and then you look at something close up, your get a picture. Your There's a muscle in your eye called the ciliary muscle, which is responsible for something called accommodation, which basically means that when you go from looking at something far away to looking at something close up, the ciliary muscles can either contract uh, or like relax to make that adjustment. But as people age, the ciliary muscle gets weakened, it atrophies. And so older people like who otherwise would have perfect vision and don't need glasses, will need like reading glasses to look at things close up. And so like do you have I forgot what state were you in again?
Pennsylvania.
Oh, okay. Like you
Yeah.
have like CVS's and Dwayne Reed and stuff like that there.
Mm-hmm.
So like if you go to the back by the pharmacy where they have all the glasses,
Yeah.
right? Those are like they're not like prescription glasses, right? They're just like so they're basically just like these types of reading glasses. And next time you go, if you ever go there, like you can take a look at the glasses and notice that the prescriptions will be positive. And that's because over here, right, we have for your convex or a converging lens, your focal length is a positive value, but if it's diverging, it's a negative value. And so remember how I said I was going to come back to this. So my prescription is this. Do you think it'll be positive or negative?
Negative.
Yep. My prescription is negative 2.75 diopters. So that means I'm using a diverging lens. So if you go to like CVS and you look at those glasses, you should see that they should all have a positive number, right? And because they're convex. And also if you feel it, like using your fingers and stuff from like the center outwards, it should bulge more in the center.
Yeah. Yeah, I feel like I used to like I think my mom had reading glasses at one point and I
Yep, yep,
definitely was playing with those.
yep, yep. So, so yeah, that should be it. So essentially what we covered was first what a the distinction between a real image and virtual image, followed by spherical mirrors or spherical lenses, followed by the basic shape of a concave versus convex, then diverging versus converging. If it's diverging, you should know like, okay, that means like if we're talking about, I mean, mostly all the time you're going to see questions about lenses. I actually don't even think I saw a mirror question, but whatever, just in case, right? So if it's a lens and it's concave, it's diverging, opposite for mirror, and then if it's a lens and it's convex, it's converging, opposite for a mirror. And if it's diverging, whether it's a mirror or a lens, will always be small upright virtual. But if it's converging, it will depend on object distance and the general like kind of pattern for the converging would be essentially if you look at this like from here to here, whoops, we have the object distance going down, which means since the focal length has to be constant, which means the image distance must go up. And since magnification is image over object, as image distance goes up and object distance goes down, the size, the magnification goes up. So we start from small inverted real to same size to large to no image, and lastly to large, but this time virtual. And and then we talked about what focal length is and how it's related to the radius of curvature, which is twice the focal length, and how it's a fixed property of that optical device, um, based on, its shape. And 1 over the focal length, if you use that in terms of meters, that'll give you the power of that lens in units of diopters. And if focal length is positive, it's converging. If it's negative, it's along with the other stuff I wrote, yeah, over here with the sign convention up here. And then lastly, its application in correcting for you know, eye problems, like yeah, vision, essentially. Make sense?
Yes, pretty cool.
Yep.
Thank you.
Mhm.
Um, like, do you have time to go over solubility real quick, or is that?
Yep. And you mentioned another thing, I think.
Yeah, I was like the gas laws, but that's just
Oh yeah.
because I, well, I feel like I kind of know them to a certain extent. I just need to like memorize like the Charles and I mean like I got the question right like in UWorld like when I was doing the practice, but I didn't necessarily like get to that yet is all. Like the difference between like Charles's laws, Boyle's law, and Gay-Lussac's law. But
Okay, yep. So,
I mean, but I feel like I understand that.
oh, okay. So,
Yeah, I think I'm good on the gas laws. I just need to like memorize which is which.
uh-huh. So, and then you said solubility stuff.
Yeah, solubilities, BME.
Yeah, is there any or like practice questions you have? If not, I can probably bring one up.
No, yeah, I feel like it'd be cool if you brought one up because I mean, I feel like I understand like the concept of solubility, but I don't necessarily know why I'm like getting those questions wrong.
Okay. Let's see. So what is solubility?
So solubility is like the ability of a substance to, I guess, like dissolve in another substance, like a liquid.
So,
To say
yeah, in a solvent,
solvent.
right? And then your oh, and then in general, like dissolves like, so
Hmm.
polar, polar, stuff like that. Um, your oh, so like okay, so your okay, so let's say that we had I can't think of maybe like barium sulfate or something like that, or yeah, I guess I can do that. So if we're talking about like, KSP, something like that, you're gonna have some solid that you put in a solvent like water, and it will dissociate into the barium ion, which will be aqueous, and the sulfate ion, which will also be aqueous. And your KSP value is going to tell you what the maximum amount of okay, so it's like let me start conceptually first. So like, okay, you could take water and you can pour some whatever salt in it and sodium chloride, and it'll dissociate from NaCl solid to Na plus aqueous, Cl minus aqueous, right?
Hmm.
Okay, so like imagine doing that with salt in like a cup of water, but now imagine you have like a huge container of salt and you put all of that in like that small cup of water. Um, some of it will be like dissolved, but a lot of it won't, right? And that's because there would be too high of a concentration, right?
Hmm.
Um, so your KSP value represents the max concentration for something to be soluble. Okay. So, let's see. Let's say we have um okay, I'm gonna draw another thing. So CuF₂, oops, solid dissolves or dissociates into Cu2 plus aqueous plus 2F minus aqueous, and the KSP is 1.6 times 10 to the negative 6. Um, well, yeah, or rather, um, okay. Now okay, so these types of problems will like oftentimes give you the, reaction uh and the KSP value, and remember that all capital K stuff is based on the law of mass action, which is basically what?
So it would be like products over reactants.
Very good, very good. And so this could be like Cu2 plus F minus. And do you remember what we do if we have like a coefficient here?
You would put it to the second power.
Perfect. Now, what do I put on the bottom here?
The Cu F F2.
Okay. And now, since it's a solid, right?
Yeah.
And you could also think of it as a pure substance. Now, it may not seem like a pure substance because it's composed of a copper, like more than, one, atom. But if you think about it, if something has a concentration, it must be like dissolved in something like water, right? Because concentration is moles of the solute over volume of like the solution.
Hmm.
So a solid compound isn't on its own, it's not dissolved in anything, so it wouldn't have a concentration value, right?
Right.
And I guess like another shortcut would just be like if it's liquid or solid, um, you won't include it. Um, so what you will include will be if it's aqueous, but also gases can work. And so for KSP, since KSP is going to be starting off with a solid reactant, you're pretty much never going to have like a denominator there.
Okay.
All right, now what we can do is we could write out because oh yeah, because like so like if they give us this information, they'll likely ask us like what's the copper ion concentration, what's the fluoride ion concentration, um, which means that we turn this into like X values. So like this can turn into just X, and then this could be what? This part is a bit.
This would be, oh wait, no, yeah, this is 2x squared.
So this is a little counterintuitive, but the 2x in parentheses squared, right?
Yeah.
And, we multiply these. What do we get?
Um, so it will be 4x plus
Plus,
x to the third.
you said plus.
Sorry, my bad, my bad, my bad. Ugh.
You really just meant to the third power.
Yeah, to the third power. No, that's my fault. I wrote down plus. I don't know. I do that sometimes. I need to stop.
Well, you said you wrote down what?
I wrote down a plus sign instead of a minus sign.
Wait, where are
My
you getting
fault.
the plus and the minuses though?
No, no, no. Sorry. Instead of a multiply,
Oh,
no,
okay.
no, no. I just messed up.
Okay, okay. Uh, if it was plus, What then?
Um, oh, wouldn't it just be a 4x squared? No, yeah, 4x squared plus x.
Yeah, go on.
Okay.
Can you like, is this something you can do?
Oh yeah, yeah, I guess you could. But wouldn't it? I'm just kind of confused. Would it be?
Well, so the answer is you can't do this because they don't have like terms, right?
Yeah, no, you can't. Okay.
Good, good, good. So yeah, 4x cubed. And then we can set that equal to the KSP 1.6 e negative 6. And yeah, let's solve for x.
Okay, so divide by 4.
Okay.
1.6 divided by 4 is probably like zero point 0.4. And then it'll be x to the third times 10 to the negative 6. And then it'll be x to the third equals zero point 0.4 times 10 to the negative 6. Like, do we take the cubed root?
Hmm.
Okay. So take the cubed root of zero point 0.4 times 10 to the negative 6. That's
Do you remember how we did that? Like the cube root?
I'm trying to remember. I'm like, don't we like change the
So let's say we have x squared and we want it to be regular x. Regular x has what exponent?
1?
And then if you have, let's say, x to the a power times x to the b power, what is the answer here?
Um, x to the a plus b.
Good. And, you know, if it was like x to the a minus x to the b,
Yeah, you would subtract it like x to the a minus x to the b. Or
so,
yeah,
so maybe you mean x to the a minus b?
yeah.
Okay. Now, what if we did x to the a to the power of b?
Then you would multiply it a times b.
Okay. So what can you do here?
Multiply it by 2. Well, I guess you would take it. You would do x to the power of 2.
Uh,
Mm.
so what do you mean by that?
So I guess you would put parentheses over x to the 1 and then put 2 on the outside.
But then that'll just get you x to the fourth is equal to x squared.
Oh, okay, yeah, never mind. Never mind. Because yeah, you have to do the same thing on both sides. You do x to the 1/2.
Yeah, over here, right?
Yeah.
Because then you see, so what I was trying to get you to do here is see that, okay, if I have an exponent taken to the power of another exponent, I multiply the exponents. right? And then here, if I don't know why I turned it just, so that's weird. I don't know why that square is there, but it's like, okay, if I if I want to get x to the 1 power, I have x to the 2 power. So I can't, mm, add anything to the 2. I can't subtract anything to the 2, but I can multiply the 2 by 1 over 2 to get 1, right? 2 times 1 over 2 is 1. So I could take it to the power of 1/2, right?
Yeah.
Okay. So now here, if we want to do the cube root, what would we do?
Multiply by 1 over 3. Take it to the power of 1/3.
So multiply by 1 over 3 or take to the power of 1 over 3.
Uh, yeah, you would take it to the power of 1 over 3.
Okay. Now, kind of hard to, well, actually, no, that works. So 1 over 3 would give us times 10 to the what power?
Mm, -2.
Yep. I kind of glossed over like the point 4 part, but good. Good, good, good.
Yeah.
So solubility problems will always essentially be something like this, but you can have a total of 3 possibilities, like either something like, let's say, AX, or sorry, something like A, or let's just, I don't know, say like B. Um, and then if they're equal, like equal amounts each X, this would turn into X squared. Okay. You could then have A and then B squared, which could then be X times 2X, oops, squared, which would give you the 4x cubed. And then lastly, you had something like this. You would get x and then in parentheses 3x cubed. And then what would this give you?
Um, 3x, no, no, no. 3 to the third is 27 times x to the fourth.
Mm-hmm.
Yeah.
Yep. So these are basically the um oops. Yeah, these are basically the 3 types that you will see in terms of the solubility. Um, right?
Mm-hmm.
Okay. So now I'm going to give you a problem here, and why don't you tell me, or yeah, why don't you try this out?
This is the molar solubility of magnesium hydroxide. Okay.
Oh, I should have said, my bad. So in all of these, when I turn it into the X, that's so like, okay, maybe I'll put it in red here. So So the KSP is the solubility product, but the X is the molar solubility. Okay. So here we're essentially just trying to find X.
Okay. Uh, supposed to tell you what I'm doing. So I like drew out the equation and it was like MgOH and then I like split it up into Mg2
Okay,
plus.
hold on. So, um, what type of charge does magnesium or oxidation state would it have?
2 plus
And what about hydroxide?
minus 1.
All right. So what's magnesium hydroxide supposed to look like?
Is it MgOH2?
Yep. With the OH in parentheses being two?
Yeah.
Yeah.
Okay. Okay, so then I have the KSP for um like the solubility constant would be Mg and then with within the brackets to the squared
You said
and
you said the mg squared?
oh wait, never mind. No. Mg's not squared. My bad. I'm getting
Oh wait,
confused.
mg2 plus.
Yeah. So it is. Let me see. No, it would be the fluorine would be squared. I mean, no, sorry, the OH would be squared. My bad.
Okay.
That'll be x times 2x squared. It's the same, like 4x cubed
Mhm.
equals 5.6 times 10 to the negative 12 um divided by 4. Wait, I'm a little goofy.
Hmm.
Is it 1.6 for 56? 5.6 divided by 4.
Okay.
Okay. X cubed 12 and then we'll multiply by 1/3
Okay.
both sides. Over 3 is 12 divided by 3 is 4. So and then it'll be for like the 1.6 to the 1/3 is I'm gonna just move the decimal point over 3 times.
Oh, well, that front number isn't gonna matter too much because, like, well, one cubed is one, and two cubed is eight. Um, And what number did he have? You said,
I got 1.6 times 10 to the negative 4.
uh-huh. Yeah. So, um, yeah. So you could just kind of think of that as like, um, kind of like one.
Okay. All right, that makes sense.
Hmm.
So then would it be B?
Very good. Very good. Very good. Awesome. And let me give you one. Mm, if you added an acid to this magnesium hydroxide that's added to pure water, let's say that you added, in addition to the magnesium hydroxide, you added, I don't know, HCl.
Hmm.
How would that affect your KSP? Oh, or, molar solubility. Uh,
Mm,
would it go up? Would it go down? Would it stay the same?
yeah, add an acid to it.
Hmm.
I think it would increase the solubility.
Yep, tell me why.
Um, because the protons from the acid will make more water with the OH from the magnesium OH, and then like the magnesium will just have more solvent to
So,
dissolve it.
so your so the hydroxide ion is a base, right? It's a pretty strong base.
Yeah,
And so if you added an acid, it would like quench or react with the base to turn it just into water, right? Which means that this will go down, right?
yeah.
And that'll push this reaction forward through Le Chatelier's principle, right?
Hmm.
Okay, what if you added some magnesium instead of the acid?
I think solubility would decrease then.
Yep, tell me why.
Because now there's more solute than solvent.
You can just kind of think of it in terms of this goes up, so Le Chatelier would cause it to cause a reaction to go more backwards.
Okay, yeah.
Because, yeah, so like Le Chatelier's principle just means compared to equilibrium, if we're taken away from equilibrium, it'll behave in a way to return to equilibrium. So, and now I'll have one more question. So, do you know what the bends is? Have you ever heard of that term?
No, is that like how do you spell that? Is it like BENDS, Benz?
Yep.
Okay.
It's not like the
Um,
medical definition or anything, but yeah.
no, I don't know. I don't know.
So, if you, let's say, dive like deep in water or whatever, you experience like a higher pressure. And so let's say that we have like some beaker of like water or something. Um Now, yeah, we can put this. Okay, so you know how let's say a can of soda has a liquid with dissolved carbon dioxide gas in it. Um and because we've been talking about solubility, but this time we're going to talk about solubility with a gas. Um when you know, so okay, when it's a closed container, there's like pressure above the liquid, downward, that keeps, the CO2 dissolved inside of it, right?
Hmm.
And when you open it up, it makes that sound and, bubbles come up and out because, well, when you open it up, it's the pressure above this liquid is dropping. And so a lot of that liquid, a lot of the gases that are soluble in that are dissolved in that liquid, can leave, right? Right.
Yes, yes.
Okay. Now, if you, let's say now, this is a person or whatever, like swimming, and the person, dives pretty deep, they experience a higher pressure, right? And then, so we have in our blood dissolved gases like oxygen, carbon dioxide. Like 20% of the atmosphere is oxygen. Most of it is like nitrogen. So as you dive deeper and deeper, um, we are providing a stronger pressure that can force the oxygen and nitrogen and those gases to force them to be more dissolved in your blood, right? And now if you ascend really, really quickly, you are reducing that pressure, which will cause the dissolved gases to exit, just like they would if you opened like a soda can.
Hmm.
Bubbles with the nitrogen come up so fast, um, that it can make you sick, essentially. And that's something called the bends because you have all of that nitrogen bubbling out of your blood at such a high, you know, rate where, it can really like harm you. Okay. So now this is called Henry's law, which can kind of segue into the gas stuff, but we can do that some other time or you can kind of do that yourself. Um but yeah, so this was just to show you that, we've talked about a solid being able to be soluble. But you could also have a gas or gases that become soluble. Um, and that would be dependent on the vapor pressure. Okay.
Yes.
All right. Anything else?
No, thank you. I mean, I guess I'm just I guess yeah, I'm a little nervous. I mean, my test is so soon.
Hmm.
Um, I guess like what would you recommend? I'm gonna take a practice test probably this Sunday. So tomorrow is just like gonna be an all day study marathon.
Hmm.
Debating if because like normally I go to yoga class on Saturday mornings, but I'm like maybe I should just could go through all day. Um, but I guess like what would you recommend like now? Like that I'm so close. I mean, I feel like I'm starting to understand the chem phys concepts, and then I'll get to like memorizing the systems for biology, and then like I want to also start memorizing psych soc as well. Yeah, I guess like, do you recommend that I just do like a bunch of practice problems now for like the next few weeks and just keep reviewing?
So you're still going to be taking your practice tests, right?
Yeah, I feel like I have to get back to that just to see where I'm at now. Like
Yeah.
fingers crossed,
Yeah. No.
like my score is going up. I really hope so.
Mhm. Um, yeah, yeah. And I guess we already talked about like pushing it back isn't like an option for you or anything like that.
Um, More than the 28th.
Um, yes.
Um, I guess I would have to see what other dates are. I mean, I don't know. Like, I guess I just didn't want to mess up my application cycle is all, but I also don't want to like
Hmm.
submit with like a low score. I mean, because like my plan is to submit without my MCAT.
Yeah. And for it to be sent when it gets released. Yeah,
Yeah.
it's like the main kind of thing with a lot like most people. It's like, you know, if you apply late, that really hurts you, but if you do it early, but you're not ready for that could negatively affect your MCAT score. So you want to find like a balance. I would say that your next full length, you can kind of, let's see, your goal was like what, a 505, a 510, something like that?
Yeah, just like I guess, yeah. Or at this point, I feel like even if I got like a 508, like that would be somewhat competitive.
Okay. So, um, hmm, because, well, I was gonna say like, like tests are always going to be like the best indicator of where you're at, and also it's good to you know uh practice with them so you just get better and better. So I'm thinking like, okay, let's say you take your test tomorrow or sometime soon, and let's say it's like a 497 or like a 500. What would you feel about that? Like, would you take that as maybe a sign to like take it at a later date, or what would you think? Like worst case.
Yeah. Yeah, I feel like worst case, like I would have to take it at a later date, which would definitely suck.
Yeah.
Um, I mean, like, I don't know. I've been seeing on Reddit that people took their exams later and they still got in, so it's probably fine, honestly. At that point, then I feel like I would just focus on trying to get my applications in at a reasonable time.
When you say at that point,
Like if I am still getting if I'm still like at sub 500, like after I take this test, that's why I'm like, oh, fingers crossed. Like, I mean, I don't know. I don't think it's like unrealistic. I'm at like a 505 or something like that when I take my test now.
Mhm.
Um,
So you're saying if you got like lower than a 500, then you would focus on getting your application in on time, or are you saying,
then yeah, if I got a 505, then I would just focus on submitting my applications and then push my test to uh the maybe like the 17th of July, which definitely sucks.
oh wait, oh sorry, so are you saying 505 on test or on your practice?
If I got a 505 on my practice, then I would still take it on the 28th.
Yeah.
Just because,
Okay. And then if not,
ugh,
yeah, I know. It's yeah, it's a tough time to be in right now because it's like okay, like I want to apply because you won't have another chance until like next year. Um,
No, yeah, I'm definitely applying. I guess I would just have to push my test to July, which is annoying.
mhm,
But I mean, I just don't want to have to spend my whole entire summer studying. Like, I
mhm.
feel like I already spent so much time studying, and I guess maybe I haven't been studying the right way, or like maybe I just had like way more content gaps than I originally thought. Um, but yeah, I guess I would just have to push my test to the 17th if I'm still at sub 500.
Okay, let's see. So let me try to think what could be like
Let me see. That's not this year. Looking at the wrong year. July 12th. I mean, because I still feel like applying like end of June, July isn't bad. I mean, still.
mhm. Got it. Okay. Let's see. Because like yeah, so like from what I see, it seems like there's a good amount of like I guess like more chem viz kind of content that we've been talking about that you're starting to like kind of like yeah, that you're starting to understand in addition to like the math stuff. So I think that you definitely have a a shot at um like higher than a 505, but like is that going to be possible like within these 3 weeks? Could be. So I guess we could aim for that. And okay. I think we can aim for that then. So,
Yeah, I don't know. I seen someone on Reddit jump like 14 points in 2 weeks. Like, I mean, I don't know how they did it, but they did it.
what were they, where do they start from?
I think they were at like a 500 and they jumped to 514.
Mm-hmm. Okay. Uh, and like, did they elaborate on like, I guess like what they did
I
specific?
think they were just focusing. They said they focused on like the MCAT logic and just did like a bunch of practice questions.
Well, I mean, that's like, who doesn't do that, right? It's like, are you gonna do like, I don't know, like SAT logic or something? But yeah, I mean, like, anything is possible. Um, it's just a matter of all of the factors of do I, first of all, know this content wise? And then, second of all, can I apply what I know conceptually to new situations and new passages? And then can I do all of that stuff that I just mentioned with high accuracy? And then lastly, can I do all that stuff that I just mentioned with high accuracy in that time crunch? And then after that, actually, probably the last one would be all that stuff that I mentioned with the accuracy and time crunch with the fatigue element, because it's not just that you have to be able to be like paying attention for like, 8 hours straight. You have to be at like 100% for those 8 hours straight. So I would say, to yeah, one last thing. Let me just take a look at the breakdown from the most recent test, 124, 124, 124, 123. Okay. So I would say that the next test that you take, um, yeah, let's see how that next test goes. So between now and when you take your next test, which areas do you think probably the areas that we just talked about. So maybe today or tomorrow, like if well, I don't know if you're going to take a test tomorrow or not, but um, you know, today or tomorrow or whatever, like we could do some more like perhaps questions on solubility, questions on optics, um, and you know, take your next practice test whenever you can, and then let's see what we can do from there.
Okay.
Like
Yeah.
yeah, like I don't want to be like, hey, you're gonna have to push it back, um, but yeah, I do want to help you like get your goal score. So, yeah, I think that could be. I mean, like you're getting higher. Like it seems like what 6 points higher than like when you took the MCAT in 2023. So, it's not like you are like spinning your wheels, like you're actually making progress, you know. Um, your CP score's been up like 3 points from that. Car score up 3 points. BB up 1 point. Psych Soc kind of the same. So I mean, yeah, you're on that. You're basically on your like the path of a higher score. So I think yeah, like a 505 is definitely doable. So I would say yeah, to take another practice test and then let's see what we can do from there.
Okay, yeah. Fingers crossed I could just get like a yeah, fingers crossed. Like I don't know. I feel like I've been working over these last few weeks. I mean, I feel like it's just a little harder for me because I work until like 5, 6 sometimes, and it's just annoying.
When you say work,
Um,
you mean like MCAT work or your job?
yeah, like my job. I mean, because I do research, but the thing is, like, when I'm like on the project, like I have to be on the phone with people, or like I'm recruiting, or like I'm in just in meetings all day. So it's like I thought I would have more pockets of time to study, but I don't have as much as I think I do when I'm like at the hospital and stuff like that.
Yeah, yeah, and you're working how many days a week?
5 days a week.
And like 8 hours a day?
Yeah.
Okay. Yeah, because most people, and I bet that person that you're talking about on Reddit that improved by that much, I highly doubt that they're working, like, let alone, full time. So, and there's no way for you to get like any breaks from that for like maybe a week or 2 weeks or anything like that.
I mean, I mean, maybe. I mean, I've been taking like days off here and there so I could like catch up and study. So like I've
Yeah.
been doing like my 3-day weekends
Yep.
and stuff like that. And I was hoping that that would help. But yeah, it would be nice if I just like took a week off. Like maybe
hmm
that's what I do. I feel like I've been using my PTO up, but I think I also have accrued more. So we'll see. I mean, at least then I wouldn't be so tired. Because I just been like drinking caffeine and like trying to stay up to do things.
Yeah,
So
yeah. Yeah, I would. I would like, yeah, see if there's any flexibility there with that because that's definitely tough if you're working that much. Um, so yeah, so I would. Okay, so I guess okay, what can we do? Um, take some or like do some solubility optics practice perhaps today, and then maybe tomorrow take your next full length. And yeah, send me an email when you take like, what you get for your score. And then like, we'll do like that thorough blind review and review to kind of really go into like what led you to like choose the answers that you were choosing and all of that stuff. And see if you can get some time off at work. Like, if it's like a research thing where like I'm sure that they are used to people that are studying for the MCAT or something like that. Maybe not, maybe I'm wrong, but be like, hey, I
I
don't
mean,
here, I don't want to be here forever. I got stuff, got bigger things to do or whatever. Um, yeah, see if you can get some time off and stuff.
yeah, I feel bad because like I've already been taking like I took time off during the month of May and
Hmm.
I took time off this month
Hmm.
and I feel bad because they like made like this little care package for me because they feel like how I'm always like trying to find like little pockets of time to study.
Oh,
Um,
that's cool.
yeah, but now I'm like, oh, I'm not taking it. Whatever, it's fine. Like,
Hmm.
yeah, I guess because like I don't want to ruin my application by submitting like a low score.
Yeah.
I mean, because I have a good like my personal statement's pretty good and I have good recs. I just need like at least like a 508. I'd be happy with that because at least that's like competitive to a certain extent. A 510 is like ideal.
Yeah. So you just have to weigh like or perhaps be like, okay, I could apply this year and like try to get a 505, but let's say worst case scenario, like that doesn't work out. The worst thing, right, is just that you would apply next year, which would be a thing that you would do anyway, like, if you don't get in like this year and stuff. And if that's the case, then you have the ability to, the ceiling is kind of like limitless in that case, because then you have, all that time. But yeah, okay, we can just work as if you're gonna take it on the 28th. So take that practice test, let me know how it goes. Um I sent you like a email with Joe. He's someone that can help you with your application as well. And yeah, so I think we can get away with having you send your application, having you take the test on, the 28th. Um, and a 505 I think is definitely within reach. Um, but yeah, we'll have more information after you take like one more test. Okay.
Okay, all right.
All right, we can work on that as a plan, and then oh yeah, and then
Yeah, I was thinking to take my test on Sunday though, just so I could have one more day to study.
yep, yeah, you could do that. Um, yeah, yeah, you could do that. Yeah, that works. That works. All right, let's see. Do you want me to put you in for next time?
Yeah,
All right, what day, what time works?
probably Monday.
Okay, what time, range or whatever?
Let's say like 11.
Okay. Okay, I put you in for Monday the 9th at 11 a.m. Eastern. And then today we did 2 hours, 22 minutes. That should be, it was 85 for you. Yeah, okay. 201.
Okay.
And all right, so yeah, good luck on the test you take on Sunday, and we're gonna try to do all this by, the 28th, or yeah, I think the 28th is when your date is, and we're gonna try to do the application and stuff. And you got the email that I CC'd Joe to, right?
Yeah.
Okay, okay. Um, and yeah, they can help with your application and stuff. Okay.
All right, cool.
All right,
Okay.
awesome. Good luck, and I'll see you on Monday. Okay. Take
All
care.
right.